Alright, so we're going to go ahead and get started here. Alright, so what we have here is, again, we're reviewing something that we did, I believe, the first month or so. So we're going to start talking about what it means to actually have an observational study and an experiment. So what we'll see here is basically our goal for our final project, because we won't have like a traditional exam, is you're going to be collecting data. You got to find a way to collect data and find a way to do it in a appropriate statistical way. So the way that that's going to work is we first come up with a question, and then we work through that process. We have a question, we have the type of data we look for, and figure out how we collect that. And the two options we have are, we can do a study, where a study, you have to randomize the way you select people, because you want to limit bias. The other option is to do an experiment, where you already have as many people as you like to participate, and you determine randomization by saying some people get this treatment as opposed to a control. So here, the first thing that we need to consider is when we have observational studies, we have about 4 options. So we have SRS, we have stratifying, cluster, or multi-state. For experiments, we narrow it down to about 3, where you do completely randomized block, and match pairs. So again, it's been a while since we've seen this, but right now what we'll do is, if you have your flashcards, some of you actually have them with you, you can go through and consider what these topics mean. So right now, all we're looking for is definitions. So take a moment, work with those at your table, try to come up with definitions, and once we have that, we'll try to add some stuff here.
Oh, they're mad. Simple random. Yeah, you do our very first ones, right? First like 2 months. 50%.
So which one are you doing here?
We have but just keep it there. It's pretty simple or similar. We don't have examples.
We haven't have any questions.
We don't have any of the experiments. We have all 4 of the typical observational studies. And then you have just the definition of observational
We know what it you kind of just seen a simple example. We have a population of 10,000 people.
We're just writing down the definition.
So say we have 10,000 people, we can number them 1 to 10,000, and then use the like. So how many people do you think would be okay? So we take 100, and because they're numbered, we say, oh, if I got number 99, so really sample statement. If you want a sample size n, you can get 1. So try to do your best to figure it out, but pretty much, yeah, you could use it. Thank
Oh, I put that too.
Population
No, this.
So, in family, the clusters are
As long as they keep
Oh, I was trying to find some.
So how do you figure out definitions?
So you split them into groups, but you only take.
Any questions so far? How are you? Oh, like sometimes it'll say, or on the AP grading, like, you look at their grading, for some reason they don't tell the difference. I think it's too big of a grading. But from my experience, I tend to say one sample when you have the variation.
No. He's like, I drink a bath water. That's Louis.
It doesn't necessarily matter. But I think the ones that I sent to you guys, they call it one sample.
That is not bad. You're not bad.
So it doesn't matter because you do the same. The calculator. So in the end, on the text, if you say one or two, they either grade that you text them or they grade it. So you guys see, if you use a calculator, you have to use your feedback. All right, so we'll go ahead and continue here. If you happen to have any of the answers here, we can put them on the board. So let's try to get some answers up here.
His paper's not even the right way.
I like money when
Oh, you do? Did you like do work or anything?
Doesn't look like anybody wants to try the experiments. If you have any definitions for experiments, we'll go over them. I have a slightly different way of thinking. Like a quick example or something, but either way. You want to add any of them?
Like pizza, pero pizza.
Algebra.
Yes, how does my dinner look?
So me and Alex.
So that's why I said 6 periods fast because I have two enemies for everything.
You know what I mean? All putting on camera.
Games.
That's goodies right there.
But you know what?
I gave it at least.
I have no shame to say that Alec is gonna be my roommate at Center.
Yeah.
Yeah. Unfortunately.
Alright, so we're gonna go ahead and get started here. So just to talk about some of the steps that we have, again, we can explain these things a number of different ways. I'll show you just how I did myself. But starting with our observational studies, we have SRS. Each sample of size something has equal chance of being selected. It says of size pass.
What is it?
Each sample of size.
Nothing really wrong, you just forgot.
Oh,
the
size
letter.
N.
Huh?
Nice. Each sample of size N has an equal chance of being selected. That's perfect, that's fine. So we can say it this way. There's a lot of ways you can put that, because somebody explained to us earlier that, like, how do you explain SRS if it's like as basic as you get? And that's true, but each sample size N is what we're looking at.
Equal chance.
So stratified, we have group. It's a good point. Notice that stratified and cluster, they're both group. So we have to find a way to differentiate.
I can help.
What do you think?
With stratified, you split the population into subpopulations and you sample each group independently.
Okay, so we sample each group independently. And how do we usually sample? So in other words, for stratified, if we have our separate groups,
Isn't it SRS
the groups, so we sample SRS of groups. But what kind of groups do we have?
homogeneous?
Homogeneous internally. In other
Internally
words-
homogeneous.
In other words, each group is different. And a common example is like male and female. Each group is different. So the groups, different groups, or they are homogeneous inside. So you have the same participant, same type of participant inside your group, but each group is different, so we take an SRS of those. For cluster, we group, but what do we know about our groups?
Heterogeneous. They represent
Right. They represent the population because they are,
internally.
Completely all
okay, so they are,
one group is completely
right, they're completely sampled. It's like taking a census of your groups, your selected groups. But they are heterogeneous internally. They're heterogeneous internally, so each, it's like saying if you look at class, like freshman through senior, you take a little bit of each class, and that is your cluster. So we take a little bit of each class, that is your cluster, because they should still represent a typical high school student.
So if there was like, for example, different classes of like third grade, would that be stratified?
If
Is it
you
all
took,
first graders?
yeah, if you took first graders and compared them to different,
Let's do.
but then again,
Wait, so you're
it's,
saying for cluster, it's like different grades, like an example, right?
yeah, you
Like
take,
one class from 9, one class from 10.
well, you would take a little bit from each class, as in freshmen, sophomores, juniors, and seniors. You take a little bit of each, and you put that into a group, that is a cluster. If you do like something more, or a characteristic, like, you're looking at a certain characteristic like gender, then maybe that's more of a stratified.
So, like, for example, a cluster would be just non-homogeneous, but it's the same thing as stratified, but they're just not the same inside.
Yeah, so inside the groups, stratified are all the same. Inside the groups, clusters are
Oh.
all different. Like they're more, clusters are more representative of the population, Strata are more representative of a particular group within your population. But in the end, we take an SRS from stratified, so now your sample looks like a cluster, because you take from every group.
Are you allowed to stratify and then cluster?
That is a good point. That's this one, multi-stage. You got it. So, yeah, so we can do multiple methods, and that's when we combine them into a multi-stage situation. So this states that you can do SRS, stratified cluster, you can do systematic, you can do a bunch of things. You can just combine them all into one. For experiments, we'll see something really similar, but as we get there, these are just some ways that I've explained it myself. So we'll go to randomized, we'll go to completely randomized. And when we do that, really what that's saying is you need to actually impose some treatments. So you give your people who are participating, some of them are going to go here and get this treatment, some of them will get something else. So that's one way you can have completely randomized. So all subjects have equal chance of receiving any treatment. You have no groups in completely randomized. For block, the only difference between completely randomized and block is we separate them into blocks like these are like strata. They're like strata because your blocks have to have some different characteristics. So it could be, again, like gender, it could be something else, age, possibly. A lot of ways you can go about that. But randomized block, you separate them into different groups. And what we tend to do with this case is we like to draw like a map where you have block 1, block 2. Then within that, you give each one either placebo or the drug, placebo or the drug. So then you compare two different ones, and we can do that